After examining the cause of surge in the previous section, we will now devote this section to the system necessary to protect dynamic compressors against surge and corresponding damage. So, in this section, we will define the objective of the surge control system, the available options to protect compressors, surge system design considerations, and finally, a history of surge system types. In order to make sure that the impeller velocity always exceeds the stated critical velocity, a number of options are available. These options mainly fall into three categories: shutdown unit before critical flow is reached, increase the relative gas velocity, or decrease system resistance. For the first option, when you consider that most dynamic compressors are in critical service, so unspared, then this option is not possible. The second option of increasing the relative gas velocity can be achieved by either increasing the speed of the impellers or by adjusting the inlet angle of the gas relative to the impeller vanes. Both alternatives result in the increase of compressor energy and should provide the higher velocity through the impeller. The third option of decreasing the system resistance can be achieved by either directly reducing process system resistance, as seen in a previous video, or by opening a throttle valve, or by directing gas flow through a blow-off or a recycle line. Of the two alternatives available, the recycle line is more efficient, since it does not affect the energy in the process system. Given the applications in which compressors are employed, it can be readily observed that option 3 is the most cost-effective way to protect compressors against surge and corresponding mechanical damage. Accepting the fact that reduced system resistance is the most cost-effective way to eliminate surge damage, a number of surge system design considerations should be mentioned. These considerations fall into two categories: compressor considerations and process system considerations. Compressor considerations include fast system response, control line automatic adjustment, ability to adjust control line to gas density and operating point changes, recycle stream cooling, and check valve location. Process system considerations include gradual process flow changes, flow reversals, startup procedure, and shutdown procedure. The figure that you are about to see now presents a chronological listing of surge system history. So first we'll list them, then we'll cover each one of them in details. The first system developed for the process industry is the surgeless applications, then surge alarm systems, single parameter systems, biased systems based on flow and differential pressure, and then finally modern systems used extensively today in the process industries. Let's start with the first system. In my professional experience, many so-called surgeless applications have been observed. These are applications where the process designer assesses the system and concludes that there is no possibility to surge the compressor. Many times, this assessment is based on system resistance alone. The conclusion being that since there are not any variable resistance points in the process system, like valves, coolers or reactors that can foul, then the compressor cannot surge. if the molecular weight and gas inlet temperature are constant and the compressor will not be subjected to mechanical damage or fouling, then this assessment is totally true. However, if any of these facts can occur, the compressor in question can be forced into surge as a result of the inability of the compressor to produce the energy required for the throughput flow. Recall that the operating point of any compressor is the equilibrium between required process system energy and the compressor-produced energy. Keep in mind that both of them can change and will certainly do. The second system encountered in the industry has been surge alarm type systems. Again, the process designer assesses a particular system and determines that the possibility of surge is minimal. In addition, the application is such that a shutdown can be achieved without significant revenue loss. Therefore, the surge system is simply an alarm or shutdown system that will stop compressor operation in the event of surge, thus protecting the machine. Be aware, though, that a full assessment should be made to determine the cost impact of such a shutdown and the potential problems incurred on the startup. A properly installed surge alarm system can eliminate these unnecessary shutdowns. Now, the reliability of these systems should be mentioned. Frequently, these detection systems are simply differential pressure switches as depicted here. Depending on the application, surge can be very violent or very light. However, in the case of low pressure applications or low molecular weight applications, the effect of surge will be minimal, and the sensitivity of the surge sensor device must be investigated to make sure that the surge event is detected. The following figure shows a single-parameter surge protection system. Single-parameter surge systems have been employed extensively and very simply consist of a flow measuring device and an anti-surge valve, as depicted here. These systems can work if properly sized and installed. However, it must be understood that a one-parameter system will not be economical in a large area of operation, as in the cases of suction throttle constant speed devices, and variable speed drives will not be allowed. The result will be unnecessary recirculation of the gas and a loss of product revenue, as depicted here. The next system shown here is the standard two-parameter or biased system that has been employed almost exclusively in the industry over the past years. This system, as you can see here, consists of flow measurement and differential pressure measurement across the compressor and results in a surge control line that roughly parallels the actual surge line of the compressor. It allows operation across a wider range than the single-parameter system, and if properly sized, can perfectly protect the compressor. The final system in the evolution of surge controls is the modern microprocessor system, which affords many options to protect the compressor against surge. These systems usually employ compressor inlet and discharge temperature inputs, in addition to flow and differential pressure for each compressor section. Examine the relationship for polytropic head as seen previously, and you will see that this approach yields a more accurate approximation of the operating point. This is because input of temperature at the inlet and discharge of the compressor allows the calculation of the following terms highlighted in blue. The other available options include compensation for gas composition changes, system backups that will protect the compressor in the event of a surge, and controller output options to enable the search system to be soft in relation to the process system. In other words, operation of the search control system will not adversely affect the process system.